Hello everyone, it's me Gagan Kumar present over here to teach you physics. Let's move on to the video. We will be discussing motion in straight line, concept about acceleration and kinematic equations and applications of kinematic equations in motion under gravity and in projectile motion. Now, the previous lecture we have completed already average velocity, average speed, distance, displacement, and based on that some questions also. Now, understand what is acceleration. Now, the acceleration is basically what? Now, definition if you write, it is rate of change of velocity. Rate of change of velocity. That means how speed of a particle is changing, like increasing or decreasing with respect to time. That one will understand from this term acceleration. And here rate of change of velocity, that is with respect to time basically. And acceleration symbol if I will give A, then this rate is nothing but it's a time rate. So d by dt, time rate. So dv by dt I'll write. So b stands for velocity. So dv by dt I'll write. Or I can write also here d by dt. This velocity is nothing but that is dx by dt. So it will be d by dt of dx by dt. So velocity in place of velocity, I'm putting dx by dt because velocity is rate of change of displacement. Now here it is coming how much? D square x by dt square. So that means you can write here it is basically double derivative of x. Suppose x is a function of time, then you have to do 2 times differentiation, will get acceleration. And if velocity is given in function of time, then 2 times differentiation, 1 time differentiation will do to get acceleration. Okay, so for velocity 1 time differentiation, and for displacement 2 time differentiation. And what is this d by dt term and all? Now in basic maths, in our YouTube video already we have completed what is d by dt term. D by dt is called basically what? Now differentiation. Okay, differentiation of t, some quantity suppose with respect to t basically. So but dx by dt means differentiation of x with respect to t, So here dv by dt means differentiation of v with respect to t. And there are certain formulas are there, but mostly we'll use most of the time dxn by dt, that is n into x to the power n minus 1, or sometimes if you are using like this one, into dx by dt will be there. And here the dt to the power n by dt, that is nothing but n into t to the power n minus 1. Okay, so this will be idea about the differentiation. If any t term is there, t square is there, then this power will come here and t power will become 2 minus 1. Okay, so t square differentiation will become 2t. Similarly, t cube differentiation will become 3t square. So this is the way we need to differentiate. Now next thing, here another formula you can write. This acceleration also can be written as dv by dt, and also I can do dv by dx into dx by dt. So here dx by dt is nothing but velocity v, and here it will be dv by dx. That means whenever velocity is given as a function of x, when velocity is given in a function of x, if v is given what? Now v is a function of x. Okay, then what you use? Now then acceleration you can use v into dv by dx. Okay, so remember this, if velocity is a function of time you can use the above relation, and if velocity is a function of x, then you can use the down relation which is v dv by dx. And how it is coming? Now here just a chain rule, we are putting chain rule of derivative and we are getting. So this is the about formula, just remember. And mostly acceleration you want to write, that is nothing but your velocity by time. Okay, or basically you can tell change in velocity by change in time. So based on that we can understand here one thing. One is average acceleration. So what is average acceleration? That is your total change in displacement. Total change in displacement divided by time taken for that change. So you can write here what basically, that is your delta v by delta t. So for a large interval, if you want to find what is your average acceleration, then what you can do? Now change in velocity by change in time. And remember here, this dv by dt is basically, this term is telling you about instantaneous acceleration. That means at a particular time, what is your acceleration? A t equal to 1 second, or a particular t equal to 2 second, particular time t equal to 2 second or 1 second. But here it is telling you the interval. Interval means like 1 second to 2 second, or some t1, t initial to some t final. Okay, so that you can get what? T final, so that you can get one time change in time. Okay, so it's a time interval, but it is at a particular time. Okay, so this is the idea you must remember about acceleration. Okay, now I'll go to the next thing. Here it is, unit and all. Remember, acceleration is a vector quantity because it is a velocity by time you are telling. So it is a definitely vector quantity, and its unit also what? Acceleration is a vector quantity, and its unit will be, SI unit will be meter by second square. Okay, because it is velocity by time, so velocity is meter by second, and by second you are telling, so it will be meter by second square. Okay, or you can write meter to meter, or you can write meter into s to the power minus 2. So this is what? Now this is your SI unit, your SI unit. And if a dimension you want to write, so acceleration dimension is what? m0 L1 t minus 2. m0 L1 t minus 2. And here, next thing understand here, sometimes you can have instantaneous oscillation. I told already, I have informed this one. So instantaneous oscillation, therefore asking sometimes, just directly you can put dv by dt, or if you average oscillation asking, then average oscillation can put delta v by delta rt. And if you remember, if acceleration is negative, if acceleration is coming negative, that means what you are understanding? Now particle is moving, but its velocity is decreasing if acceleration is coming negative. So that means it is called basically what? Now deceleration, or you can call it as retardation, or it is called retardation, deceleration or retardation. So when acceleration is negative, and when acceleration is positive means what? It is accelerating actually. So object is accelerating. You can tell here object is, or particle or on a body is accelerating. Okay, that means its velocity is increasing with respect to time. Its velocity is increasing with respect to time. Okay. And here if acceleration is 0, if suppose acceleration is 0 coming, that means here two things can come, either velocity constant or velocity 0. So if velocity is constant, then acceleration will be 0, because instantaneous acceleration we are telling dv by dt. If a constant we are taking as velocity, then constant derivative with respect to time will be 0. So that's why if velocity is constant means it is called particle is moving in uniform motion. Particle is moving in uniform motion. If velocity is 0, then particle at rest. Particle is not moving, particle at rest. There are two conditions can happen. And if acceleration is 0, and if any frame where acceleration is 0, it is called basically what? It is called non-inertial frame. If acceleration is not equal to 0, then it is accelerating frame. Or if acceleration is 0, right here, acceleration 0 means it is called basically inertial. It is called inertial frame. That means here not accelerating frame, not accelerating. And if acceleration not equal to 0, then you can call it is non-inertial frame or accelerating frame. So it is inertial frame or not accelerating frame. Okay, so this one also you can understand. So remember this word, if acceleration is 0, then it is inertial frame or not accelerating frame. And if it's inertial frame, what it can be? Now when is either a particle or an object is moving in uniform motion, that is also called inertial frame. Or it is at rest, that is also inertial frame. If acceleration is not 0 for a frame, for frame is like observer, like suppose you are observing a particle is moving here, and you are observing from certain frame. Okay, so if acceleration is 0 for that frame, then it is called inertial frame. And for inertial frame, there are two conditions. This frame can either moving with constant velocity or velocity 0, because for both the cases acceleration is 0. So this type of idea just remember sometimes if question comes. So this is about your acceleration. Now we'll go to the kinematic equation. After that we'll understand some uses of acceleration there. And remember here, when we talk about earth surface, that time here what acceleration we take? Now here acceleration we take basically what? Now g. So it vertically downward. So this is g is vertically downward we take. For each and every point on the earth surface vertically downward will take. So this is your earth surface. And this g value is nothing but how much? Now it is called, its value is basically 10 meter per second square, that is approximately, but g value I can write, it is 9.8 exact value. In SI unit it is meter by second square or approximately 10 meter by second square. Okay. So whenever there is a confusion coming about options while solving about g, then this is the accurate value 9.8 you take. Or if easy questions are given or 10 value is mentioned, you can take also 10. Okay, but 9 point will be it is accurate value. Now here, this is the earth surface, acceleration always vertically downward, it is acting towards center. And this type of acceleration is called what? Now this acceleration is called acceleration due to gravity. Acceleration due to gravity. So G is called what? Acceleration due to gravity. So this is the idea you must have about acceleration. Next, we'll check some kinematic equation and applications on that. Now here, right next heading, kinematic equations. Kinematic equations. Now here, the first equation is basically V equal to U plus at. So what is V? Now V is your final velocity and U is initial velocity. And A is what? Now A is a constant acceleration. So remember here. So A is what? Now here A is basically constant acceleration. Okay. So remember when acceleration is constant, that time only you can use this type of equations whatever I'm going to write now. So one I already wrote that V equal to what? U plus at. And another one V square equal to U square plus 2S. And number 3 S equal to ut plus half at square. Okay. So all the meanings I'll write here. So already I told V equal to final velocity and U is initial velocity, and t is a particular time given. At any time t, my final velocity is initial velocity plus acceleration times t. And here another formula I'll write s nth. What is s nth? Now this is u plus a by 2 into 2n minus 1. So this is called what? Now this is the distance traveled by a particle in nth second. Okay. So the particle is moving. In question it is asking in nth second, in fifth second, what is it, sir? Displacement or distance. Then you can tell u plus a by 2. Initial velocity will be given, or if it is telling initially at rest, then u will be 0. It will be a by 2 into 2n minus 1. So that type of questions we'll see. So this remember distance traveled by a particle in nth second, which is u plus a by 2 into 2n minus 1. Okay. So in kinematic equation, this 4 equation is very important. Whatever questions comes based on this only. Okay, we need to understand how to apply these equations and which equation to apply, and where you are getting time or velocity according to questions where to apply. Now let me write here, this V is nothing but, that is your final velocity, and U is initial velocity, and S is displacement. And one more thing, understand about these equations. These equations can be used in either in x-axis. Okay, that means if I write here Vx, I have to write here Ux and Ax into t. That means here Vx equal to Ux plus Ax t. That means whenever you want to calculate x-axis velocity or horizontal velocity, that time you take x-axis initial velocity and x-axis acceleration. And time is not relative actually. So for time, normally we keep time. We will not write that t in x-axis and all. That type of questions also we'll try to see. Now, this is the idea about displacement and all. And remember, this all questions that all equations, whatever we are going to apply in problems, based on what? Now, constant acceleration. Okay, if constant acceleration is there, then after you can use this. If an acceleration is not constant, then we need to do like this. Suppose you know a equal to dv by dt, and here dv equal to how much? A dt. Now from here you have to do the integration. Actually this equation is coming from here only. So when you do this integration, if a is constant, a will come out of the integration. Then after you can take here uv 0 to t. So we write this one as how much? V minus u equal to constant are coming out, and dt integration is t. So that will give you v equal to u plus at. So this thing is happening when acceleration is constant. Okay, but if acceleration is not constant, simply integration will do and limits will put. Some questions, sometimes acceleration may not be constant, it is a function of t. So you can do here acceleration, you can substitute and you can do the integration. So this is the idea you can remember. Okay, and here from this they can ask questions like what is the displacement ratio between 7th second and 5th second, displacement ratio between nth second or n minus 1 second or n plus 1 second. So this type of many questions can come here. Okay, now first application we'll see for kinematic equation. The first application problem, right? That's right, applications of kinematic equation. Okay, so first understand, let me take a heading, stopping distance. What? Stopping distance. So what is stopping distance? So let symbol give S. Okay. Suppose I have a floor here. In this floor, okay, one particle is traveling, okay, or one car is traveling. Okay, one car is traveling and it's traveling with an initial velocity u, and this velocity is constant. Traveling with initial velocity u and this velocity is constant. Now what happens? Now at this point this car is applying the brake. At this point applying, then what will happen? Now here after some distance traveling, it is stopping somewhere. Okay, on the same road it is moving in a straight line only. So after traveling some distance, it is stopping. It is stopping somewhere. Okay, so if it is stopping this car, then how much happen velocity? Now velocity will become 0. Okay, so what is happening? A car is moving with the initial velocity u. Now when it is applying brake here, after some time it is stopping here. Okay, it is stopping here. So what is happening? It's final velocity becoming 0. Now in the question what they'll ask what is this stopping distance, or what is the distance it traveled before coming to rest. Okay, at this point it applying the brake, what is the distance traveled before coming to rest, just before coming to rest, like that type of questions can happen. Now listen here, so here simple idea will apply. What? Now initial velocity u, final velocity 0, and here displacement given s. Now I can choose this equation, second equation, v square equal to u square plus 2as. So here I have written equation, so v square equal to u square plus 2as. So I can choose that equation. Now here I can apply final velocity is 0, so 0 square, initial velocity is u square plus 2 into a into s. Now here if I want to find a, so how much it is coming? Minus u square by 2s. That means here my acceleration whatever coming, it is negative. So negative acceleration means deceleration or retardation. So sometimes also u square and stopping distance will be given, and they'll ask about retardation. So here the retardation is nothing but minus u square by 2s. Okay, and here if you want to find s, so the magnitude I want to find s, then how much it is? Now it is u square by 2a, u square by 2a, or you can write basically mod of minus u square by 2a. Okay, so here what is this one? Now this is your stopping distance. This is your stopping distance. Okay, so try to remember stopping distance is what? U square by 2a. Okay, that means whatever distance it traveled, how much it is? Now it depends on square of the initial velocity, what initially it was moving, divided by 2 times acceleration. Okay, that acceleration is nothing but that is just retardation. That is the negative acceleration or deceleration. Okay, so here some questions will be how? Now some questions will be like this. S is directly proportional to U square. So write S1 by S2 is how much? U1 square by U2 square. That means for a certain object, if stopping distance is given and initial velocity is given, and for the same object they are telling some initial another initial velocity or velocity telling, we are asking again what is the stopping distance. So you can use these relations because S is directly proportional to U square, so S1 by S2 is nothing but U1 square by U2 square. So directly you can apply. Okay. Otherwise sometimes this will be direct question. This particle is moving with 10 meter per second and here it is applying the brake and stopping. Then you stopping at a distance 1 meter. Okay, suppose S is given 1 meter, this is 10 meter per second square, 10 meter per second. So 10 square by 2 into 1. So that is 100 by 2, it is 50, minus 50 meter per second square coming. So that will be a retardation. So this is a normal thing, just to understand the things here. What? Now formula understand. Okay, if stopping distance it is asking in question, then it will be not a difficult job. You can calculate easily. Okay, if I remembering the concept clearly, what is about stopping distance. Okay. Now next we will go to motion under gravity. Okay, next we will go to motion under gravity. Motion under gravity will see what is the application of this distance and all. And based on these questions, we'll do in the next class. We'll try to solve. Let me complete the things whatever it is there. And also we have many questions we can get from this acceleration and all from this formula. There will be given displacement, velocity or acceleration. Okay, they will ask you to find something, time and all. Okay, so that type of things we'll try to see. And this kinematic equation, little application we'll see. After that, you can solve many questions. So you come to next number 2 thing in application. Right, motion under gravity. Motion under gravity. Motion under gravity. Okay. Now here, first let me take as a case 1. So what is this case 1? A particle is there on the floor. A particle is there. This particle is just throwing upward with initial velocity how much? U. Initial velocity U. Okay. Then what is happening now? This particle is reaching certain point. Particle is reaching certain point. And at that point what is happening? Its velocity becoming 0. Then after that it is again falling down. It is coming back. But in this condition what I am telling, I am just considering particle is going up. That's it. So here what is happening? A particle or a ball, a ball is thrown vertically up. Is thrown vertically upward. Up means vertically upward it is thrown. Okay. Now here there are so many things we can find it here. So here it is this much height, whatever height it is coming, this height is called H max. This height is called H max, and the maximum height particle is reaching. Or at any arbitrary point, we can find also what is the velocity. What is the velocity of the particle at any time t. And also you can find what is the time taken. If a particle is going here to here, what is the time taken by the particle we can find. Okay, there are many things we can find. So let me find one by one. So first I am writing time taken to reach maximum height. Time taken to reach maximum height. So this one will try to find that maximum height. So this will be sometimes a direct question or indirectly with a linked question it can come. So this will take number A. Take number A. So what you do? Now time taken to reach maximum height. Now here to here it is going and velocity becoming 0. Here U. Now understand here if acceleration I want to tell, acceleration will be how? The acceleration will be vertically downward. That means here the acceleration is opposing the motion. So here vertically downward, and that acceleration is nothing but how much? This A will be actually negative. So minus G it will be, okay, because it is vertically downward. Okay, or it is opposite to the direction of velocity. Velocity is upward this way direction, but it is downward. Now here, let me write the equation. I know v equal to u plus at, and if you go to the maximum height, your velocity will become 0, and u is what? U, and a is nothing but minus gt. From this expression I can get t equal to how much? U by g. T equal to how much? U by g. So the time taken to reach maximum height is nothing but initial velocity by acceleration due to gravity. And this g value will be mentioned in questions either 9.8 or 10. If nothing is mentioned, you put both the value, check answer. If it is matching with 10 and also with 9.8 options are there, then 9 answer you choose always. If a 9 answer is not there, then put 10 and check the things. Okay. So remember 9.8 will be accurate answer it will give. Sorry, 9.8 and 10 is approximately, but most of the time g value they will mention. Okay. So in meter per second square they will mention it is 10 meter per second square. So time taken to reach maximum height how much? T equal to u by g. Okay. And after finding time taken, another thing you can find here, that is maximum height attained by the particle. Maximum height attained by the ball. Okay, or by the particle also you can tell. Now what is the maximum height attaining? Now here maximum height we have taken h max, it is going upward actually, h max. So what is h max? You can use this formula, s equal to ut plus half a t square. Now t already know, you can substitute there, or you can put also v square equal to u square plus 2s. This equation also you can get. So whatever both the equation apply, you will get this. Now here if I put, so here how much will come? S equal to, s means that is maximum height. So maximum height h equal to u into u by g plus half into, it is going upward, vertically upward it is going. So it will minus will come. So g will be minus into u by g square. And you calculate this and you check, your h maximum will come. Your h maximum will come how much? H max will come u square by 2g, Okay, and here also same thing, final velocity 0, substitute everything, you'll get u square equal to 2g h max. Okay, in place of a I am putting minus g and v equal to 0, so u square will come this side, and here a minus will get cancelled. So you can write here u equal to root under let's write here h max we need to find. So write h max equal to u square by 2g, So this is the idea, remember. So whatever maximum height you are reaching, that is nothing but how much coming? Now this is your u square by 2g. So if initial velocity given in question, then maximum height easily you can find whatever particle will reach. Okay. And if any time t you want to find velocity, then what you can do? Now you can do Vt equal nothing but u minus gt. Vt equal to how much? U minus gt. So because here u initial velocity there and acceleration due to gravity is minus g, so it is how much? U minus gt. So Vt equal to how much? U minus gt. So this much thing you must remember about what? In a motion under gravity, the case 1. In the case 1, what I am telling, a ball is thrown vertically upward. Now next thing, see, if you vertically thrown upward, then automatically another thing will be happening. What is that? Now case 2 happening, that is your particle is freely falling. Okay, so here right, it is just a dropped case, Okay, that means suppose I am throwing this pen upward, then what is happening? This particle, it is going, this pen is going and again it is falling back, automatically falling. Okay, so when I am throwing, just once I am throwing, it is going and reaching a maximum height. After that, it is falling automatically. So that case is happening automatically. So here what we can do? Now here this is just a dropped case or just a raised case. So here from upward there is no velocity given. That's why initial velocity will be 0. and finally it is reaching to the ground. So it is reaching here ground. So here it will hit with some velocity v just before reaching the ground. And in the question what they'll ask what is the velocity at which it is hitting the ground. Now the velocity is nothing but that is equal to, if height you know, this height you know, height how much? So but let's take height is h. Then velocity will be root under 2gh. How it is coming? It is coming from the same kinematic equation. So v square equal to u square plus 2s you apply and you get it. So just directly I am writing here. So what is this formula? Now velocity at which ball is hitting the ground or object is hitting the ground. Okay, hitting the ground or just before hitting the ground. Okay, just before hitting the ground, this is the velocity. After hitting it, its velocity will become 0. Okay, so this is the idea, remember. And when it is coming from the same height, that whatever this h max you have taken or h taken, so here you will check maximum height whatever you have taken h. So the same maximum height it is. So this h max is same. Okay. Now here, if I want to find time, whatever time it is, time taken to come here to here, the time is nothing but it is same thing, 2h by g root. Okay, so already we have calculated here. So it is coming how much h? It is u square by g, and it is basically here it is u by g, and you can check also here. So u is nothing but 2g h max, and if I put here, so this time also can be written as what? Now 2h max or 2h by g, like this also you can write. This is the time also 2h by g or 2h max by g. So that h max is nothing but that is h only. Let's take h max is basically nothing but that is h. Now here 2h by g. So this is your time of descent, and the time of ascent is what? Now time of descent means what? Time of descent means it is coming down. Whatever time it is taking to come ground, that is the time of descent. And this is your time of ascent. This is your time of ascent. That means whatever time it is taking to go from this ground to maximum height. Okay. So now here what you can write? Now here you can write one thing also. Time of ascent is equal to time of descent. Okay. So when a particle you are throwing from certain reference, from here particle you are throwing, then particle is going to a maximum height, and from that maximum height particle is again coming back to the ground. Okay, and if it is thrown with velocity u, it will hit the ground with same velocity u, and at final point its velocity will be how much? At a maximum height velocity will be 0, and whatever time taken here t ascent and here time taken t descent, that will be equal. That means what you are understanding now, this motion in 1D or motion under gravity, okay, this upward downward motion are symmetrical. Okay, so at this point its velocity is how much? U. When it is coming its velocity u, but opposite direction, that's it. Okay, so according to time also, if any other intermediate distance or intermediate velocity you are taking, same thing will happen. Okay, that means you can understand, suppose I am taking a particle here. This particle while going itself it is having some vt velocity, then while coming itself it will have same vt velocity but downward direction. It is upward direction, it is downward direction. This is the symmetrical nature you can understand. And time of descent, time of ascent, and this one you are understanding. And remember, this case is automatically happening when you are throwing, or once you are throwing, it is upward motion happened, automatically downward motion happened. And here this acceleration due to gravity is g, and it will be positive also. Okay, because it will help the particle to come ground, so that's why it is a positive here. And the velocity at any time t you want to find, that is how much? That is u plus at t, but here as u is 0, so at velocity at any time you want to find is g times t you can put. Similarly other equations also you can write. So in any other distance st you want to find, it is half gt square. Okay, at any time t you want to find displacement from the top, then you can find also half gt square. Or if you want to find something v square equal nothing but 2g st. Okay, at any time velocity also like this also you can write. Okay, so because e equal to 0, everywhere I am putting e equal to 0, I am getting the expressions. Okay, so this is what? Like just a dropped case. So just dropped means like this one, particle like this is just dropped. Okay, so based on this, remember, when a particle once upward you are throwing, then total time it is taking to coming ground, how much you know? So once particle thrown upward, so here suppose particle once you are throwing with initial velocity u upward, okay, So let me write here directly. So particle is going and reaching here for the maximum height position. Then again it is coming back and hitting the ground with the same velocity u, and the total time taken. So it is going and it is coming. Okay. So let me write here up to maximum you are taking. So you take like this. Time taken to reach ground. Time taken to reach ground is how much? Now t equal to 2u by g. Okay, why 2u by g? Now because going time, that means going up time, it is time of ascent, that is u by g, and time of descent u by g. Addition of both is coming basically 2u by g. So once you know initial velocity, suppose I am telling 10 meter per second particle is thrown vertically upward, then what is the time it will take to come ground? So time taken to reach ground, total time basically it is. Okay. So total time how much? Now t equal to u by 2u by g. So 2 into 10 by 10. So 2 seconds it will take. Okay. And here remember this condition is what? Now when particle is thrown upward. When particle thrown upward. Particle thrown up. More specifically tell vertically upward. Vertically upward. Okay. So when particle is thrown vertically upward, then after the t equal to nothing but 2u by g. 2u by g. Okay. So this much thing you must remember about this. Now the next thing comes here. Case 3. So what is this one? Now here a particle is thrown vertically downward. Suppose you are throwing a particle vertically downward, and if you are throwing a particle just you are dropping, then this is the second case you can do. Okay, that second case is a continuation of first case, or normally if you are just dropped, a particle just dropped from certain height, then you can find what is the time and what is the velocity it is hitting. Okay, what is this distance and all, everything you can find. It's not an issue. Now here a particle is thrown vertically downward. That means here what you are doing. Now here one floor is there or earth surface is there. Now from here one object is coming, but intentionally you are throwing the particle with initial velocity u. So from this reference you take, this is your height from where you are throwing the object. So from this h your height from where you are throwing the object vertically down. So in this case if you want to find what is the velocity it is hitting the ground, this is your final velocity v, which is nothing but u plus gt. U plus gt. Why u plus gt? Because u is there, u is not 0. U is there, u plus gt. Or you can write whatever time taken, or you can write here as height is given h, then you can write it is u square plus 2ah or 2gh. Okay, u square plus 2gh, and here I one root 1 rule will be there. So because v square equal to u square plus 2s, from that formula I am getting. Or you can do this, or this expression also at a particular time you can write. At a particular time you can write. So it is better you keep this formula here itself. So you write u square plus 2gh, root will be there, and here you can use what? Now here it is vt at any time t. So here to your time you can calculate, that is not an issue. So vt equal nothing but u plus gt. Okay. So here at any time t, what is your velocity? Now whatever initial velocity, then u plus gt. In between any intermediate place where a ball like that object is there. And here to your suppose it is distance traveled in st. Then how much I'll write that st is nothing but how much? Now distance or displacement traveled in time t. That is how much? Now u times t plus half gt square. So this equation also you can substitute. So for this one, for s. Okay. Now this is the idea you must remember when particle is thrown vertically downward. So this is the conditions are coming. Now whatever we taught, we studied about this one, we try to see based on what? Now based on questions. A particle is thrown from a top of the tower and what is the thing is happening there. So this both cases, case 1 and case 2 together combined we will see. Okay, now come to the next slide. Here I have a tower. Suppose I am telling I have a tower here. In this tower I have one object O, So this is a tower, object O, or object or ball, whatever. Now I am throwing this object with 10 meter per second. Okay, 10 meter per second, vertically upward. So I am throwing vertically upward. Now this height of the tower is given how much? 40 meter. Height of tower is 40 meter. Now find the time taken by the ball to reach ground or bottom of, okay, to reach ground, right? Ground is the time taken by the ball to reach ground is what? Option A 1 second, option B 2 second, option C 3 second, option D 4 second. Okay, so this is the question you remember. On a height is one tower is there here. From this tower one ball you are throwing. And this ball is going what? Now going vertically upward. And that height of the tower is 40 meter. And vertically upward velocity is given 10 meter per second. Okay, now if you reach the bottom of the tower, then we need to find what? What is your time? What is the time taken? Now try to analyze here. Here two cases together you have to solve. Now here, this is the reference you consider. This is considered as a maximum height, whatever it will reach. When vertically you are throwing, it is reaching that maximum height. So in this maximum height, its final velocity is 0. So here to here, some height is traveling small h. And here to here, total height you can write is capital H. Okay, so what is this capital H? Now that is basically 40 plus small h. Now first understand, if particle you are throwing with 10 meter per second, this will be the maximum height you can reach. That means this height, if you want to calculate, you can calculate how much it is. Now initial velocity is u, so it is a upward motion, so it will be u square by 2g, and g value you consider as a 10 meter per second square. 10 meter per second square. Now u square by 2g, so it will substitute. It will come how much? Now h will come. Okay, u square means 100 by 20, so it will come 5. So that means your h is coming how much? 5 meter. So 5 meter it will go maximum. After that, it will vertical, it will come down. So case 1 and case 2 both are together here. This is case 1. So it is coming what? Vertically down, which is a case 2 case. Just dropped case. Okay. So here what we can write? Now you can write here. This is your initial velocity equal to 0. And if this height we know, we can find what is the time also. This time is nothing but 2 into h by g. So here one time is coming, let's take t2. And here to here it will take some time. The time you write is t1 because I need to find the time here. They are telling time taken by the ball to reach the ground. Okay, now see here. So this here t1 how much? That is u by g, and u is given 10. So if 10 by 10 I'll substitute, I'll get 1 second. So t1 is 1 second. And if h I'll calculated already, if I'll substitute here, it will get 45 meter. This total height is 45 meter. And if I substitute here, it is 2 into 45 by 10. So which is 9 root 45 into 2, 90. 90 by 10 is 9. So 9 root is 3, actually plus minus 3. But as time is there, so time is always positive. So we are moving in arrow of time. So to take it positive only, no need to take negative. So one time is t1 is 1 second, t2 is 3 second. Then total time is t1 plus t2, which is 1 plus 3. 4 second. So 4 second it will take to reach the ground. So this is the way you can calculate. And there are other things you can calculate. You can tell at what velocity it is hitting the ground also. And at intermediate any distance also you can find what is your velocity and all. So this is the way you need to solve the questions. Okay. And this motion under gravity and all cases actually, here you should have idea about equations and whatever special cases and all. After that you need to work out according to the questions. Okay, so a little mind work will be happening there. Sometimes some direct question won't be there. So here part wise questions will be there. Here upward motion happening, here downward motion happening. So you have to remember upward equations, you have to remember your downward equations to find the other parameters, okay, or physical quantities. Okay, so I hope you understand. Now little discussion will do about projectile motion, and more questions will be discussing the next class about total motion under gravity and kinematic equations questions. Okay, now let's just understand projectile motion, some idea I'll give. So this is not motion in straight line, that is a motion in 2D, but let me discuss some concepts there. Okay, direct some concepts. Okay, the same kinematic equation will apply, but we apply here in a 2D we will apply. Okay, and it is a very important part for your NEET exam. So projectile projectile motion. Now listen here. So that application of kinematic equation only. So here that two things are happening. So here you are having y, here you are having x, and here one object is there, and this object you are throwing with initial velocity how much? With initial velocity u, with initial velocity u in this direction, Okay, what direction? Now direction making an angle theta with horizontal axis x, and here is a vertical axis y is there. Now what is happening? Now this particle is going in a path. So this path is basically what? Now a parabolic path. It is a parabolic path. Okay, it is a parabolic path it is going, or you can tell in a parabola it is going. And here initial velocity is given you. There are many things you can calculate here also. So by taking the help of what? Now kinematics equations. And I told if v equal to u plus at I am writing, then same equation I can write in two ways. I can write vx equal to ux plus axt, and also I can write vy equal to uy plus ayt. The similar approach I'll do here. And here if you understand, if this u in x-axis there will be velocity component, initial velocity component, that is ux, that is u cos theta, and here it will be uy, that will be u sin theta, u cos theta and u sin theta. And here if this particle is moving here, and this will be the maximum point. So this is your maximum point, and this will be your maximum height attained by the particle, the maximum height attained by the particle. Now here this velocity how much? This velocity, right here only vertical velocity is 0 and horizontal velocity ux will be there, that is here nothing but u cos theta, and here vertical velocity how much? 0. That means particle is not going this way, particle is coming back, and here that the direction, in vertical direction whatever velocity is there, that velocity is becoming 0. Now one more thing understand here. In this case acceleration in y-axis, that will be your minus g, okay, or g basically, acceleration you can take g, it will be there, and acceleration in x-axis how much? It is 0. So here acceleration in y-axis is there, so it is vertically downward, it is there acceleration, so g acceleration is there, but in x-axis there is no acceleration, so that's why there is no change in this component of the velocity. So initially how much it is? Now it is u cos theta at this t equal to 0, so at t equal to 0 at origin. Okay, what is the particle velocity? Horizontal velocity u cos theta, same horizontal velocity everywhere. Okay, wherever a particle goes, if particle is coming to here, then its horizontal velocity how much? Same thing, ux equal to u cos theta. But ui will be just changing the direction here, so it is vertically upward, but here now it is vertically downward, and initial velocity whatever you are thrown, the same it will hit here, so that will be there. Okay, and here to here, suppose this point you give, this point is a, this point is b, this point is c, so a to b some time taken is how much? That is basically u sin theta by g. Directly you can calculate here, and I'll check. Just now we did these questions, motion under gravity. So case 1 concept we did. So what first I'm writing time taken by projectile to reach maximum height, projectile to reach maximum height, time taken by the projectile to reach maximum height. How much it is? Now this is your t, small t take, that is u by g, and which u? Now it is vertical velocity. So vertical velocity is uy by g I am writing. So previously we are writing the motion in under gravity, we are writing u by g. So but here I am writing what? Uy by g. So uy is how much? Now that is your u sin theta. So it is u sin theta by g. So time taken to reach maximum height by the projectile is 2 u sin theta by g, or uy by g, or vertical velocity by acceleration due to gravity. And remember, this theta is nothing but this theta, whatever we are telling, this theta is called angle of projection. Angle of projection, which is made from where? Now from horizontal axis to that you are throwing the velocity direction, it is horizontal axis. So it is angle of projection. Okay, so theta is angle of projection. Now next thing, right here, number 2, total time it is in the air, or that is basically called time of flight. Time of flight is capital T. So for how much time particle is in the air, that means starting from here it is ending here, but this much time it is in air. Actually particle is floating, so particle is going like this. So what is the time of flight? Now time of flight is nothing but, that is capital T is 2 times t, or basically you can tell 2 uy by g. Okay, or you can write 2 u sin theta by g. Okay, so just now I told in the motion under gravity also, whatever time you are taking to go up, same time will take to come down. Okay, time of ascent equal to time of descent. So time of flight calculation is nothing but 2t, or 2 into uy by g. So directly you can write 2u sin theta by g. Okay, so this is the easy thing. Remember, this formula based questions will be there, so that's why slowly just I'm calculating what is the formula is there. Okay, because these things you need to remember. Now next, number 3, remember. Okay, maximum height reached, or maximum height attained by the particle. Maximum height attained by particle or projectile. So as projectile we are doing, let's write projectile. Okay, so it is a vertical direction thing again. So it is a vertical height you are taking. So vertical height you are taking means vertical equations you have to take. So here uy you know, time you know, so easily you can find it out. So how much it is? Now this h max is nothing but, so it is your uy square by 2g. Okay, just remember, for motion under gravity we find it is u square by 2g. Similarly here also writing u square by 2g, but it is uy, vertical velocity, and vertical velocity square if we will take, it will become u square sin square theta by 2g. So this is your what? H max. So maximum height attained by the particle is nothing but how much? Uy square by 2g, or u square sin square theta by 2g. Okay, so this much things you have to remember for the projectile motion. One more thing also there, that is your horizontal range. Okay, let me complete that. So let me write here. So number 4, if I want to find horizontal range, or normally you can tell range also, that symbol you can give a capital R. So what is this range? Now this R will be nothing but, it is ux into capital T. So why ux into capital T? Because horizontal direction there is no acceleration, and if we substitute also xx equal to ux, okay, t plus half x t square, because here to here time taken basically capital T, a to c. This time taken is what? This time taken is basically a to c time taken, that is t. but this time taken is what? Now A to B. Remember, A to B you are coming, whatever time taken, that is u sin theta by g. But A to C you are coming, whatever time taken, that is 2u sin theta by g. So that's why capital T I am taking, and as this one is 0, so this term total is 0, then here r equal to nothing but how much? Ux into t. So I can substitute here. So u cos theta, ux is u cos theta, and t equal to nothing but 2u sin theta by g. 2u sin theta by g. So everything can right here. U square sin 2 theta, u square sin 2 theta by g. U square sin 2 theta by g. Okay. So this is the just normal applications, whatever you are getting here. And apart from this also there is some trajectories there. For this one we can find it out also. So what is the trajectory of projectile? So this 4 to 5 formula you must remember along with the concepts based on this. So velocity is like this, here this velocity is like this, and this total ux horizontal component velocity is not changing. And sometimes they can ask what is the momentum here. So momentum is here, it is mass times velocity. Suppose the momentum at the highest point you want to find, it is mass times ux velocity. Or kinetic energy you want to find at a highest point. Okay, at the highest point kinetic energy you want to find, that is half m ux square. Okay, there are many things you can do. So if concept to remember, you can find it out what is the momentum, kinetic energy, like that. Okay, so this much idea you must remember. Okay, now let's write what is the trajectory. That trajectory normally we told what it is. It is a parabola path or parabolic path. Okay, it is a parabola like coming. So equations we'll see for trajectory. So let's write me here. Written up to 4 completed. So let's write fifth one. So equation of trajectory. Equation of trajectory. Equation of trajectory. Okay. Or path of the particle. Trajectory means path of the particle, how particle is traveling. If traveling in straight line or parabola or circular path, okay, that is the things you need to find. So here, if you find the equation relation between y and x, okay, so because yx is axis you are taking, so this is basically relation between y and x. So you'll get y equal to x tan theta minus gx square by, okay, u square cos square theta. So 1 2 will be there also. 2 u square cos square theta. Or what you can do here, now you can little modify this y equal to, you can take x tan theta common, it will become 1 minus x by r. So this 2 equation remember. So by after this modification, so this r is what? R is horizontal range. R is horizontal range. R is horizontal range. And here this is the equation of trajectory relation between y and x. Okay, trajectory means you have to find the path actually. So this is the relation between y and x. So it is a parabola coming. So y is directly proportional to some x square, like that one it is coming. Okay, and x also there. So it is your parabola equation or equation of trajectory, you can tell. Okay, so y equal to x tan theta minus gx square by 2u square. U is basically initial velocity, cos square theta, and or another formula also you can write. U equal to how much? X tan theta into 1 minus x by r. So there are different form they will give. From there you can find it out. Suppose for this one I am telling. So questions will be how here. Now here questions will be, suppose y is given, okay, root 3 x minus okay x square by 9, something like this it is given. Okay, now what you can do here, now here you can take common root 3x, it will become 1 minus x by 3 root 3. Okay, 1 minute here. What we'll do here, actually here root 3 is not there, I have to multiply root 3 here, divide here also root 3, so it will become 9 root 3. Okay, so 1 minus x by 9 root 3. Now here this one you can equate. This is your coefficient coefficient of what? Coefficient of x. So this coefficient of x you can equate. This is your tan theta. So from here you can find angle of projection, and this one is nothing but you can equate to r. So this is your horizontal range or range basically. So range is nothing but how much? It is 9√3, and here you can put what? It is tan theta equal to √3, or theta you can find how much you can find. Tan theta √3 means, remember, tan theta is sin theta by cos theta. So tan √3 is nothing but tan theta equal to √3, and theta is nothing but, you can write it is theta equal to 60 degree. Theta equal to 60 because tan 60 is √3. Okay, because sin theta by cos theta, sin 60 is √3 by 2, cos 60 is half, so it is √3. So theta equal to 60 degree you can calculate. So angle of projection. So this type of questions will be there. Normal questions here. Simple thing. Just you need to know this expression. Then you need to modify here to here like this. So these two equations are similar. Here coefficient of x is tan theta. Here coefficient of x is √3. Now tan theta equal to how much? √3. Then theta equal to 60 degree. Easily you are calculating angle of projection you are telling. Okay. So this is just for example I told here. And remember this equation is nothing but it is a parabola equation because y, x square things are there. So it is a parabola equation. Along with this equation you will need to remember this all things. Next class will be solving some MCQ based on this projectile and motion in 1D. This is based on this formula will understand. Okay. So time taken to reach maximum height u sin theta by g. Total time of flight is 2u sin theta by g. Maximum height is u square sin square theta by 2g. And horizontal range is nothing but u square sin 2 theta by g. Because 2 sin theta into cos theta is sin 2 theta. So that's why u square sin 2 theta by g. Okay. So I hope you understand better. Next class we'll solve MCQ. We'll see you later. Thank you. Thanks for watching. Like and subscribe Vidhyalakshmi NEET Academy channel. All the very best.